Hello, Mr. Wilma's PreCalc 4th hour class. Hope this finds you doing well. We are live at West High School. You are looking in on lesson 9.3 for probability. So, here we go. Probability, just a couple more different rules today. Remember on the calculator we learned in 9.1 how to use the calculator for combinations and permutations and factorial and all that jazz. So anytime you're trying to find a probability of an event that has equally likely outcomes, you take what you're looking for divided by your sample space. That can be a bunch of different ways. So if you're looking at 2 dice, the chance that you're going to roll a is 4 out of 36. The chance that you're going to roll a 12 is 1 out of 36. Okay? So find the probability of rolling a sum divisible by 4 on a single roll of 2 dice. So we're going to roll those 2 dice. So divisible by 4, that's going to be divisible by 4. 4 is divisible by 4, so that's 3 over 36. 8 is divisible by 4, so that's 5 over 36. And 12 is divisible by 4, so that's 1 over 36. Now, we have to determine what do we do with those numbers. Well, I can't roll and would mean you multiply or would mean you add. I can either roll a 4 or an 8 or a 12. I can't roll a 4 and an 8 at the same time. So we would add those two together, which gives you 9 over 36. So you've got about a 1/4 chance of rolling a die that is divisible, 2 dice that are divisible by 4. Okay? There you go. All right, so a probability function is a function that assigns a real number to each outcome. Remember, if you're going to add all your probabilities up, you're going to get 100%. So your answers are going to have to be between 0 and 1, like 50%, 75%, 10%, whatever. So just make sure you're looking at that as you're doing these. All right, if they're not equally likely, then you're going to have to figure out a way to kind of go through this or find the different ways to go. But let's work through some of these, okay? So strategy for determining whether they're equally likely or not, and then determining whether it's and or, combination, permutation. Let's try. Dylan opens a box of a dozen chocolate creams and offers 3 of them to Russell. Russell likes vanilla the best, but all of the chocolates look alike on the outside. If 5 of the 12 creams are vanilla, what's the probability that all of Russell's pick are vanilla? There's 2 ways you can do this problem to arrive at the same answer. Let's try it with combination or permutation first. So would we use combination or permutation? Does it matter the order that he picks them out? No. He has no control over that. So our sample space is going to be how many total chocolates are in the box? A dozen, so there's 12. So 12 choose. Well, how many is he picking out? Russell is going to offer 3 of them. So 12 choose 3 is going to be our sample space. Okay? Then we've got to figure out what our outcomes can be. Well, how many of them are vanilla? 5. How many is he picking? 3. Once again, the order does not matter. So you would take 5 choose 3 divided by 12 choose 3. If you do that, book goes through it on the next slide for you, you end up with 1 over 22. Okay? So 5 choose 3 divided by 12 choose 3. So 1 over 22. You could also use the multiplication rule in that same thing of just multiplying your probabilities together. So remember, we got 1 over 22. So if the probability that A occurs, then B occurs, and then C occurs, you just keep multiplying them together until you're finished. So same exact problem. What's the chance on the first draw that Russell picked a vanilla one? Well, 5 of them are vanilla out of 12 total. So he's got 5/12 chance to get his vanilla one. Times. You have to assume that he picked a vanilla one out. So if he took a vanilla one out, how many vanillas are left? 4 over, well, he took 1 out, 11. Times. Third draw, he's drawn 3 of them. How many are left that are vanilla? 3 over 10 equals. If you do all that on your calculator, you end up with 1 over 22, which is the same thing that we got before. So figure out what you're looking for divided by your sample space, and usually there are some options for you on how to get that. So write down there 1 over 22, how we did that problem. Okay, conditional probability, we're not going to get too much into that, but let's see if we can get that to work here on another probability type problem. Suppose Tommy makes 92% of his free throws. If he shoots 15 in the free throws, what is his chance? And if his chance of making one is independent, meaning his one shot doesn't affect the next, what is the probability that he makes all 15? Well, what's the chance that he makes the first one? 92. Times, what's the chance that he makes the second one? 92. Times, all we're going to end up doing here is taking 0.92 to the 15th power. So if I take my calculator out and I go 0.92 to the 15th, 0.286. Got about a 28.6% chance of making 15 straight free throws if he makes 92% of his shots. Okay? So figure out which way you got to do it and then go from there. We don't get too ridiculous with these. But there we go. So 0.286. All right. I'm going to go through this one, 23 and 24 on bid euchre. It's like FEF. If you've played that before. So let's go through 23 and 24 here. Bid euchre that uses 24 cards consisting of 6 cards of each suit. There's 4 suits. So what is the chance that the hand is all spades? Okay, so we got to figure out our sample space. Well, how many total cards are there in the pack? 24. Do we have any control over the way that these come out? No. Choose how many cards are in each hand. 6. Okay? So that's going to be our sample space, and actually that's going to be our sample space for 24 because we're still talking about the same game here. Okay, now we got to figure out what our outcome is. Hand is all spades. Well, there's 6 spades in the deck. How many hands have all spades in them? 1. There's only 1 hand that you can get that has all the spades. So the chances that you're going to get all spades is 1 divided by that. If you do that on your calculator, you can leave it as a fraction, but it comes out to be 1 over 134,596. Okay? So not a very good chance to get all 6 spades, but you would think that it probably wouldn't be that good of a chance because there's only 1 hand out of all of those that's like it. Okay, all 6 cards are from the same suit. Well, how many suits are there? 4. So there are only 4 hands that are all there. So instead of a 1 up here, this just turns into a 4. So you got a little bit better chance than you did before because you're dealing with 3 other suits. And if you do that on your calculator, you get 1 over, I think, 33,690. So 1 over 33,690. Let me double check that. 649. Sorry about that. 649. Okay, so there are some problems